Hello students, now I am going to explain the second problem in eigenvalues and eigenvectors. Find the eigenvalues and corresponding eigenvectors of the matrix. This is a 3 by 3 square matrix. Let us assume A is equals to this. The characteristic equation is mod A minus lambda I is equals to 0. So characteristic equation diagonals you should take minus lambda. 8 minus lambda, rest all right same. Here 7 minus lambda, here 3 minus lambda, rest all right same. Now multiply 8 minus lambda into 7 minus lambda into 3 minus lambda, minus 4 for the 16. Formula is minus, here minus into minus plus, but formula is minus, so 4 for the 16 plus here plus minus plus, so here minus into minus is direct plus 6 into minus 6 into 3 minus lambda, minus into minus plus 2 for the 8 plus 2 into minus 6 into minus 4 is plus 24 minus 2 into 7 minus lambda is equals to 0. Now 8 minus lambda into first term into this total term minus second term into this total term minus 16 plus 6 into minus 6 into 3 is minus 18 minus into minus plus 6 lambda plus 8 plus 2 into 24 send minus 2 inside minus 2 into 7 is minus 14 minus into minus plus 2 lambda. So here now it becomes 7 into 3 is 21, 7 into minus lambda is minus 7 lambda, minus lambda into 3 is minus 3 lambda, minus into minus plus lambda into lambda, lambda square minus 16. That only I have written here, plus 6 into theorem right constants, minus 18 plus 80 in one bracket plus 6 lambda plus 2 into 24 minus 10 is 10, 24 minus 14 is 10 plus 2 lambda is equals to 0. Now 8 minus lambda into 21 minus 16 I have written in constants in one bracket. Here see lambda values minus 7 minus 3 is minus 10 lambda plus lambda square plus 6 into minus 18 plus 8 is minus 10 plus 6 lambda plus 2 into 10 is 20 plus 2 into 2 lambda is 4 lambda. Now 8 minus lambda into, so 21 minus 6 is 5 minus 10 I wrote as it is plus lambda square. So minus plus into minus is minus 6 10 the 60 plus 6 into 6 lambda is 6 6 the 36 lambda 20 plus 4 lambda I wrote as it is. So now multiply 8 into this total term, next minus lambda into this total term minus 60 plus 36 lambda plus 20 plus 4 lambda is equals to 0. So 8 5 the 40, 8 into minus 10 is minus 80 lambda, 8 into lambda square is 8 lambda square, minus lambda into 5 is minus 5 lambda, minus into minus plus lambda into 10 lambda is 10 lambda square, minus into plus is minus lambda into lambda square is lambda power 3 minus 60 plus 36 lambda. This I wrote as it is. See here constants, 40 plus 20 is 60 plus 60 minus 60 gets cancelled directly. Now write like terms, so minus lambda power 3 plus lambda square terms separately, 8 lambda square plus 10 lambda square plus lambda terms minus 80 lambda minus 5 lambda plus 36 lambda and 4 lambda in one bracket is equal to 0. So here minus lambda cube plus 18, so 8 plus 10 is 18 lambda square, here minus 80 minus 5 is minus 85 lambda, here 36 plus 4 is 40 lambda is equal to 0. Now first two terms I wrote as it is so minus 85 plus 40 is minus 45 plus into minus is minus 45. Why? Because here big number is having negative sign. So here overall we can take minus lambda common minus taking common means negative will become positive, positive will become negative, negative will become positive. So here power 3 will change to power 2, power 2 changes to power 1, here simply constant. So minus lambda is equals to 0, here lambda square minus 18 lambda plus 45 is equals to 0. So here if you send minus that side, 0 by minus 1 is nothing but 0. Here it is a clearly quadratic equation in terms of lambda, that is a lambda square plus b lambda plus c is equals to 0. Here a is equals to quotient of lambda square is 1, quotient of lambda is minus 18, constant c value is 45. Now do a into c. 1 into 45 is 45. 45 prime factors. 5 9 is 3 3 is. So 45 can be written as, so 5 3 is 15. So here 3. 15 plus 3 18. So here minus 8 is 18 is there. So sum if you do means, if you take minus 15 minus 3 minus 18 with same numbers, minus 15 into minus 3 how much, minus into minus plus 15 3 is 45. So this becomes, so for this minus 18 can be written as minus 15 lambda minus 3 lambda, that only I have written and first and last terms I have written as it is. From first two terms we can take lambda common, so lambda minus 15. In last two terms take minus 3 common, so lambda minus minus taking common means negative will become positive, positive will become negative. So in 3 table take common means 3 1 the 3, 3 5 the 15. So here lambda minus 15 is common. What is the remaining term? Lambda minus 3. So next, lambda minus 15 equal to 0, lambda minus 3 is equals to 0. So here minus will become plus, here also minus will become plus. So 0 plus 15 is 15, 0 plus 3 is 3. So what are the eigenvalues you got? Lambda is equals to 0, lambda is equals to 3, lambda is equals to 15 are the eigenvalues. Case 1. If lambda is equals to 0, then corresponding eigenvector is a minus lambda e into x equal to 0. That is this one only. A value x means x1 x2 x3, here 0 0 0. See here these you can solve using echelon form, by using row operations, or by cross multiplication method. So I am doing this problem by cross multiplication method, that is 8x1 minus 6x2 plus 2x3 equal to 0, minus 6x1 plus 7x2 minus 4x3 is equal to 0, 2x1 minus 4x2 plus 3x3 equal to 0. So any two equations taken solve by using cross multiplication method for equation 1 and 2, that is x1 x2 x3. So here minus 6 2 8 minus 6. Here in second equation 7 minus 4 minus 6 is 7. So x1 by, so cross multiplies, minus 6 into minus 4 is plus 24. Formula is minus 7 to the 14 is equal to x2 by 2 into minus 16 is minus 12. Formula minus, here value minus, so here plus 4 8 the 32 is equal to x3 by each 7 the 56. Formula is minus, here minus into minus plus, but formula is minus, 6 6 the 36. So 24 minus 14 is 10, minus 12 plus 32 is 20, 56 minus 36 is 20. So here clearly we can cancel all zeros. So we will get the next step is x1 by 1 is equal to x2 by 2 is equal to x3 by 2. Let us assume that as k. So x1 by 1 equal to k, x2 by 2 equal to k, x3 by 2 equal to k. If you do cross multiply, if you send this value that side, multiplication will become, division will become multiplication. So k only, here division will become multiplication. x2 equal to 2k, here also x3 equal to 2k. Therefore eigenvectors corresponding to lambda is equal to 0 is x1 x2 x3 is, x1 is k, x2 is 2k, x3 is 2k. Take k outside. What are the remaining terms? Nothing there means 1 2 2. Next case 2, lambda is equal to 3, then corresponding eigenvector is this one. In diagonals you have to substitute 3. In case 1 directly 0 is there, I have written directly based upon this. So now you have to substitute lambda is equal to 3. 8 minus 3 in diagonals, 7 minus 3, 3 minus 3. In this condition, in place of lambda 3 3 3. So it becomes like this. So here also I am doing cross multiplication method. 5x1 minus 6x2 plus 2x3 equal to 0. I am taking only two equations enough. So minus 6x1 plus 4x2 minus 4x3 equal to 0. Solve by both equations we get x1, x2, x3. Here minus 6, 2, 5 minus 6. Here 4 minus 4 minus 6, 4. So if you do on going like this same process, you will get x1 by 2 is equals to x2 by 1 is equals to x3 by minus 2. Let us assume k. So these values if you take separately is equals to k means it becomes x1 equals to 2k, x2 equals to k, x3 is equals to minus 2k. Therefore eigenvectors corresponding to lambda is equals to 3 is what we got 2k, k minus 2k. So I am taking k outside. 2, 1 minus 2. Next case 3. Eigenvectors corresponding to lambda is equals to 15. So just in place of this lambda you substitute 15 in diagonals. So if you get substitute you will get like this. Here also I am taking first two equations only, that is first two rows. So minus 7x1 minus 6x2 plus 2x3 is equals to 0, and minus 6x1 minus 8x2 minus 4x3 is equals to 0. Solving about two equations we get. So same method, first we have to take minus 6, 2, minus 7, minus 6, and here minus 8, minus 4, minus 6, minus 8. So if you do simplification you will get like this. So here we can cancel with 20 table, 21s are 22s are 22s are equal to symbol is there, we can do cancellations directly. Let us assume k. So if you assume k means separately if you write you will get the result as like this. Therefore the eigenvectors corresponding to eigenvalue lambda is equal to 15 is x1, x2, x3. Here 2k minus 2k k. So send k outside. I am taking a common k. What will get 2 minus 2 1. So problem is completed. Next problem. So determine the characteristic roots and corresponding characteristic vectors of matrix A. So eigenvalues, eigenvectors or eigen characteristic vectors or characteristic roots one and the same. So let us assume A is equal to this one. The characteristic equation is lambda minus A minus lambda is equal to 0. So therefore in place of diagonals take as minus lambda directly and simplify here now. 1 minus lambda into 2 minus lambda into 3 minus lambda minus 2. 2 ones are 2. So minus 0 into something is 0. Here minus 1 is there. I wrote minus 1 as it is. Here 2 ones are 2. Minus 2 into 2 minus lambda is equal to 0. So 1 minus lambda I wrote as it is. Now first term into this total term minus second term into this total term. I wrote this as it is. So here minus 1 into I wrote 2 as it is. 2 into 2 is 4 minus 4. So here minus into minus plus 2 into lambda is 2 lambda. So now multiply 2 inside 2 3 are 6. 2 into minus lambda is minus 2 lambda. Minus lambda into 3 is minus 3 lambda. Minus into minus plus lambda square minus 2. Minus 1 into 2 minus 4 is minus 2 plus 2 lambda is equal to 0. So 1 minus lambda into 6 minus. So minus 2 minus 3 is minus 5 lambda plus lambda square minus 2 plus. So here minus 1 into minus 2 is plus 2. Minus 1 into plus 2 is lambda is minus 2 lambda is equal to 0. So here 1 minus lambda I wrote lambda square as it is. Here minus 5 lambda I wrote as it is, constant one side 6 minus 2 plus 2. Here in these two you can take 2 common, what will get 1 minus lambda. So here this becomes, I wrote this as it is, 6 minus 2 is 4. So entirely you can take 1 minus lambda common. So if you will get lambda square minus 5 lambda plus 4 plus 2 plus 2. So 4 plus 2 is 6. So this is the equation you got, So clearly it is a quadratic equation, this part. So this is in the form of a lambda square plus b lambda plus c is equals to 0. So this becomes what is the value of a quotient of a, quotient of lambda square is how much? 1. Quotient of lambda is -5. Constant is 6. So here a into c is 1 into 6 is 6. Prime factor 2 3 da. So if you take -2 -3 you will get -5. Some condition is satisfied. With same numbers product, -2 into 3 -3 is +6. So in place of -5 what we can write? -2 and -3. That only I have written lambda square -2 lambda -3 lambda +6. In first two terms we can take lambda common, so we will get lambda -2. Here last two terms you can take -3 common, you will get lambda -2. Here we can take lambda -2 common, we will get lambda -3. This is the remaining term. Therefore 1 minus lambda is equal to 0, lambda -2 is equal to 0, lambda -3 equal to 0. Send minus that side plus, here send minus plus, send -3 that side, it will come plus. So lambda is equal to 1, lambda equals to 2, lambda is equal to 3. So case 1. These are the eigenvalues. Therefore what are the eigenvalues? Lambda is equal to 1, 2, 3 are the eigenvalues. Therefore if lambda is equal to 1, then corresponding eigenvector is this same formula. So in place of this condition, in place of lambda, what you should substitute? 1. So you will get like this: 1 minus 1 0. Rest all same. Here 2 minus 1 is 1. Here 3 minus 1 is 1. So simply if you take here first x1 0 x1 plus 0 x2 minus x3. So 0 into something is 0, 0 is something is 0. So minus x3 is equal to 0 we can take directly. That is x3 value is 0. Next consider second row. x1 plus x2 plus x3 is equal to 0. Let us assume x2 is equal to k in this equation. So write x1 as it is, x2 means k we assumed, x3 we got 0. K plus 0 is k. Same k that side plus will become minus. So 0 minus k is minus k. Therefore eigenvector corresponding to eigenvalue lambda is equal to 1 is x1 x2 x3 equals to how much you got? Minus k, k 0. Take k outside. So what is the remaining values? -1 1 0. Next, if lambda is equal to 2, then corresponding eigenvector is, so in place of this condition you should substitute here how much in place of lambda? 2. So this becomes, therefore if you do simplification it becomes like this. So now consider, either you can take first row or second row, both are same only. If you take here minus divide by -1, so that's why I am taking second row. So here x1 plus x3, so here if you do on simplification, here x1 plus x3 is equal to 0. x1 plus x3 is equal to 0. Now put x3 is equal to k, then it becomes x1 plus in this x1 plus x3. So x1 plus k is equal to 0. Send k that side plus will become minus. 0 minus k is minus k. Now here consider third row, 2x1 plus 2x2 plus x3 equal to 0. So what is the value of x1 you got? Minus k. x3 value we not got. So x2 value how much you got? So x2 we not got, x3 value we got k. x3 we got k. x3 we got k here. So here small mistake is happened. So okay, here 2x2 write as it is here in place of this k. Now minus 2k, says I am writing this step again. So minus 2k plus 2x2 plus k is equal to 0. So minus 2k plus k is minus k. Minus k plus 2x2 is equal to 0. Is equal to 0. So here send minus k that side, 2x2 is equals to 0 plus k. So x2 is equals to 0 plus k is k. So if you simplify this, x2 is equals to k by 2. So here also changes will come, here x2 value is how much? K by 2. x3 value is k. x3 value is k, x1 value is minus k. So here also changes will come, so what is the changes here? x1 value is minus k, and x2 value is how much? K by 2, and x3 value is what we assumed, x3 value here k. So if you take k outside, what are the remaining values? Minus 1, 1 by 2, 1. So with this here some small mistake is happened, that's why. Next, case 3. If lambda is equals to 3, then corresponding eigenvector is, so in place of lambda you should substitute 3. If you do simplification you will get like this. So now I am taking first two equations. So minus 2x1 plus 0x2 minus x3 is equals to 0. Here x1 minus x2 plus x3 is equals to 0. Do solve these equations by cross multiplication. x1 x2 x3, here 0 minus 1 minus 2 0, here minus 1 1 1 minus 1. So if you do simplification you will get like this value summa. Therefore eigenvectors corresponding to lambda is equals to 3 is, so minus k, k, 2k. Take k outside you will get minus 1 1 2. So problem is completed.